Next item we want to make sure we take a look at this here is the ellipse. It's kind of like a circle, but it's squished one way or the other. But also overlaps with parabola by saying that we're going to have a focus, right? We actually have two of them. So that's the foci, and those are those points listed in red, F1 and F2. And they are on the inside, right? So it's kind of like that parabola, that it would open to the inside. So that makes sense for the focus. A couple other things that we have is we have a major, okay, so that's going to be the longer of the two, and we have a minor. Those are two axes. So the major is listed with a value and negative a if it's centered around the center, 0, 0, around the origin, and then the minor is listed as the b and negative b. Okay, if it so happens to be a vertical, what you'll notice is that means the major, the a value, is now on the y-axis. Notice your foci are still located in the center. And the biggest thing to remember about an ellipse, how you know you're working with an ellipse, is it must be equal to 1. So it doesn't matter which way it is. So remember that major is going to be a squared. So as it turns, you notice that it now is under the y. So whichever one's larger, that's the major. That's the major idea, no pun intended. So we'll be able to figure out where it's at, and if it's on the x-axis versus the y-axis, that's also going to tell you about the foci. Alright, so that's a lot of stuff to digest. So let's start just picking this apart and see what you have to do with it. So we want to be centered at the origin. So the center is at 0, 0. We have a vertex at negative 6, 0. That's also going to be at positive 6, 0. Okay, if it's centered around 0, 0, these are all going to be the same distance apart. The covertice is 0, 3. Alright, so that means that's a y value. It also means that b equals 3. B squared, notice we needed that in our equation, is then 9. Notice that's a y value, so I have y squared over 9. Well, that is a covertice, which means we're talking about a minor. So that means x squared, because we're centered around the origin, so nothing else in the numerator. And if the vertice was 6, or negative 6, squared gives me 36, and it equals 1. So that kind of walks us the whole way through what we need to do. All right, let's try it again. Centered at the origin, so the center is at 0, 0. We're going to have x squared plus y squared. We want it to be equal to 1. Now this time we're going to have a vertex. So that's going to tell us about a major. And that tells you a equals 5. Notice where it's at. It's on a y value. So that means 5 squared is 25. If this is an x value, here it's also b, and that means we're talking about a minor. So if b equals 2, b squared is 4, so we're able to write our equation. Now there is a relationship between a, b, and c, and we're talking about c being the foci. We said a was the major, b was the minor. So we're talking about the foci is equal to the major minus the minor. Okay, so that's a and b. So it doesn't matter if it's tied to x or if it's tied to y. If it's the major, we're going to subtract the minor from it. We're looking at a squared minus b squared. That's going to give us c squared. So c again is for the foci, to find those values in between. So let's do that. Remember, it has to be equal to 1, so we have to divide by 225. This is kind of counter to everything we think about when we're solving. Normally we want everything else to be 1 or solved for. Here it doesn't happen that way. So 25 over 225, that's going to give me 9. 9 over 225 is going to give me 25. 225 over 225 gives us 1. Well, 25 is bigger, so that's now a squared. and this is now b squared. So b equals 3, a equals plus or minus 5. Why is that important? Well, if we want to get a graph, that tells me about the major and the minor. Let's see if we can get this counted out here. Nah, not going to fit. Alright, we tried. So y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's my major. 1, 2, 3. There's my covertices. So we're still working around the center here. Notice nothing else in the numerator, so nothing else we can do with that. Alright, so now what they're asking for is what are the foci? Well, the foci is the major minus the minor equals c squared. So that's going to give me c squared equals 16, so c equals plus or minus 4. Remember, that has to be inside part of what your ellipse is, and if we're talking about the major, they should be on the same plane, right? The same axis. 1, 2, 3, 4, and 4. Okay, so we go to make a sketch. Here's our beautiful ellipse. We have some foci on the inside. That's actually not too shabby. Alright, so foci 0 plus or minus 4. We have vertices at 0 plus or minus 5. And we have covertices at plus or minus 3, 0. I have to work a little bit backwards this time. Whispering Gallery. If you've ever been to the Science Center, the Whitaker Center up in Harrisburg, they have something like this. They have just the two parabolas on either side, and you can whisper into it. It bounces off there. You get to hear it on the other side. It's pretty neat. My kids like it. Anyway, if we read through the whole thing, the major axis is 120 feet. What's that mean? That means 2a equals 120. So a is 60. The minor axis, mi, is 72. 2b is 72. b is 36. So our relationship c squared equals a squared minus b squared. C squared is equal to 60 squared minus 36 squared. C is 48. How far apart are the foci? So that means I need to double this to find out that 2C is equal to 96 feet apart. Alright, we still have to write this thing, and what's always going to happen is we're going to be given some parts that we know and some parts that we need to find out. So if we want to write the equation, we know it's going to be x squared, y squared, it's equal to 1, and it sure looks like this is going to be the major. That means my vertices are plus or minus 8 with 0, so it means a equals 8. So a squared equals 64 there on the x-axis. So that's going under here. We could guess and say that this is what 2, 4, 6. We could take a guess and think that that is right on, and that's not an issue. But what we have to do is say that our foci are plus or minus 5 with 0, which means c is 5, which means c squared is 25. C squared equals a squared minus b squared. 25 equals 64 minus b squared. We'll subtract 64 and then divide by a negative, so b squared equals 39. And sure, I could find out what the square root of 39 is, but remember what goes in the equation is b squared. So if my task is only to write the equation, then that's all I need. What we'll find out is the square root is a little bit more than that 6, what it looks like in the graph. So not everything is exactly what it seems. We do have a problem set here to work through. center at the origin for the first set, so it's not a problem at all. We'll get to translating these later in the chapter. Remember, it doesn't matter if it's first or last, the larger one is your major, so it identifies which way to go. And be very careful when you get up to number 20. Remember, it has to be equal to 1. So although common sense would say I can divide by 3 to try and get 1x squared, you actually have to divide by 9. And that should work out.